Hi, my name is Jennifer Osborne. I am the founder of Eco Wool, and I'm here to talk to you today about reimagining the possibilities of wool. Sheep have been a part of Canada's agricultural landscape for a very long time. We had a peak of 3.6 million head during the 1930s, and in 1918, the Canadian Cooperative of Wool Growers was established. At the beginning of the 20th century, there was over 300 woolen mills in Canada, and they employed over 10,000 people. After World War II, the use of natural fibers due to the availability and cost of petroleum-based fibers, wool declined considerably, and in the 1970s, there were around 500,000 sheep in Canada. Today, there are less than 50 woolen mills in Canada, down from 300 from the turn of the century. Most of these mills are mini mills, and none really focus on industrial wool products. The lack of processing is in all stages of the processing chain, no matter the fiber. We do have a very effective wool collecting system, though, with the Canadian Cooperative Wool Growers. They have traditionally sold in the international market for the past 50 years, but since that time, the international market has declined, and really there is not much of one anymore, particularly for the type of wool that Canada produces. So a brief overview of what wool does currently in Canada. Generally, the wool is shorn by the shearers, and often it's separated between belly wool and clean wool. Depending on the time or location, it can be burned, dumped, composted, or brought to the landfill. But generally, once the wool is separated, the belly wool and the clean wool go in separate bags to the wool growers, whether that be directly to the head office in outside of Ottawa or to a depot. And then wool growers will either kind of grade it and sell it on the international market. It will store it. And at the moment, a lot of it is now currently sitting because the wool market has declined so much. If a farmer decides to not bring it to wool growers, or they specialize in specific fibers, then the farmer themselves will take it to a scout, take the wool to be cleaned. This could be to a scouring plant or to a mini mill, where everything happens. At a mini mill, everything is processed on site, and that is where a lot of our local yarns come from. If it is taken to a larger scouring plant, it is then shipped to further processing, often overseas, occasionally, very occasionally, to local processors. So there are a handful, but they are very rare. So since the 1930s, the International Wool Textile Organization has collected and categorized an awful lot of wool. There are currently 36 members, which account for 24 countries. And the members deal with all different aspects of the textile pipeline, from farms to the retail and manufacturing. So what we have here is the global textile supply, and wool is less than 1% of the global textile supply. Polyester on the very left-hand side is over 50%, and cotton is second with approximately 25%. Everything else will end up being less than that. Wool is, yes, approximately 1%. Silk is almost non-existent. Cellulose takes up between 6 and 10%, and bast fibers such as flax take up approximately the same amount. So there's a lot of growth potential for wool in textiles. So here I have the 2022 numbers from the IWTO about the wool they collected from their members. So in 2022, they collected approximately 2 billion kilograms of raw wool. Out of that, they cleaned 500 million kilograms, and that is all grades. Out of that cleaned wool, 175 million kilograms was considered suitable for interiors. 125 million kilograms is suitable for apparel, so this would be for coats and sweaters. And then 200 million kilograms would be considered a fine merino, so that is what you would have in a lot of the undergarments that are very popular. The wool that was not cleaned, according to the IWTO, equaled approximately 1.5 billion kilograms. So as you can see, this is not a problem just for Canada. This is a problem that is worldwide. And if you consider that with wool being 1% of the global textile supply, this is an issue. Particularly when a lot of wool globally does not fall into that 500 million kilograms of wool that has been cleaned, that there's a lot of potential. The other thing to keep in mind here is that this is just through the IWTO. There are a lot of countries that do not get collected in this system, and they are also trying to deal with the wool that they have. So once again, it's not that the wool is useless, it's just we have not focused as a society on how to utilize this wool. So what does Canada's annual wool clip look like? So we collect approximately 1.75 million kilograms of wool per year. This, as you can see, falls into many different categories. The chart you have here that you are looking at is the different classes of wool that Wool Growers has determined was collected. Now, these numbers are slightly older. They are from 2012, but the numbers will not have shifted that much. As you can see, if you look at the top, the sweaters, which is classified as 2B, makes up approximately 3% of our annual wool clip. So what does 2B mean? This means that it's 23 microns or under, has a staple length of 2¼ to 4 inches, and has a maximum vegetation amount of 2.2%. So approximately 30,000 kilograms falls into this out of the 1.75 million. The majority of the wool that we produce in Canada is very suitable for carpet industrial wool. We have another 14%, which is also suitable for that, but it is slightly different. So the next slide, we will kind of dig down a little bit into what the classes are. We have approximately 14% of the wool that is suitable for coats and carpets. A lot of the other wool, a lot of the multicolored on the top left-hand side, really is not that good quality, but it can be used for industrial uses. Now, we at one point used to have a lot of this processing to be able to deal with this wool, but we no longer have it. So next we'll look at what the classes mean. So here we have what the classes are according to Wool Growers of what a typical Canadian clip looks like. A little bit of background on wool classing. It is not what we often look at as kind of fine, medium, or blood counts. This is a whole different system that seems to differ slightly across the world. Now, to become a wool classer and wool grader, it takes a minimum of 2 years. So this is a very highly specialized job. So please do not take what I say as an authority by any stretch. Kind of like cutting up primal cuts for meat. Every country has a slightly different way of looking at things. So first of all, we will look at the 2B, the 23 microns, the finest wool collected in Canada. So it is a solid white. It is considered a medium wool, so kind of it's not super fine, it's not fine, it's medium, it's tough, but it's still very nice. And so as you can see there is 50,000 kilograms of that. The 3B, which is considered a medium wool as well, but it is closer to 25 microns, there is 250,000 kilograms, also white. Once you get into the 7B, the RLC, the 4D, the FLP, and kind of go further down, we are getting into wool that is far less usable. So the 7B is considered coarse at 33 and up microns. So that is what we would definitely be our industrial wool. So, good for carpets and kind of industrial felting. The rest is also coarse. Some of it is white, some of it is broken, it has too much vegetation, it has been contaminated with different colors. So we end up having an awful lot of wool that is not suitable for traditional textiles. So on the right-hand side, the wool use by class here is clearly the largest bar at 1.2 million kilograms is the industrial wool. This would be considered insulation wool. So at the very bottom, there is the clothing wool. And in between those, they're at 250,000 kilograms. There's the coats and carpets. So these are your traditional kind of pea coats, fisherman's coats, and of course, woolen carpets. And at the very top there, the same amount is no known use. So this is really, really low quality wool. Once again, it's not that this wool is bad. It is just we don't have any way of processing the resource we have here. So wool is a fiber. It's a really unique fiber. It's like nothing that is out there. Humanity has not been able to replicate all of wool's qualities in a synthetic. So first of all, one key point of wool is it's sustainable. The sheep need to be shorn no matter what. So this is a sustainable, renewable resource that happens every year. It's a byproduct of our food system. Something a lot of people don't realize is that wool is very fire resistant. So it actually takes over 500 degrees Celsius to ignite wool, for it to go kind of actually ignite, to go poof. What's also interesting is it does not melt. So if you have a house fire and you have polyester curtains or bedding, it will actually melt, drip, and cause more fires, whereas wool is self-extinguishing. So wool is also biodegradable. If you put any kind of natural fiber into the ground, it will break down. The amount of time it takes to break down varies depending on the amount, thickness, and length of wool, but it doesn't shed microplastics and it breaks down naturally. Wool is highly odor resistant. Now, if you're a farmer, you may not think that, but it is. A lot of fibers will actually absorb odors out of the air. What is unique about wool is it actually will lock them in until they are clean, so until they are washed. It also absorbs a greater variety of chemicals as well. It is known for actually absorbing some, they're called volatile organic compounds, and they are everything from benign to being toxic. But wool absorbs them, so even just having a wool carpet, wool curtains, wool bedding, wool furniture, wool stuffing, it traps them and keeps them there. Wool is also, it regulates heat and moisture. This is the job it has to keep the sheep healthy. So it does this naturally. If you've ever lifted a wet wool sweater, you'll be well aware of how heavy wool is, how much how much water it can absorb. It's also really well known for being able to get wet without losing its insulating properties. And once again, I'm going to go back to number one, that this is a byproduct of our food system, and we are using 1% or less of it within the world. What happens if we think of wool as more than a yarn or textile, but as a resource, and a resource that has different properties that can be used in different areas? So number one here, we have soil health. Wool has a lot of very interesting natural properties that are excellent for our soil, with the potential to replace kind of more chemical or human-made supplements. First of all is the insulation. So wool is insulative naturally. It's what it does for the sheep. Once it's taken off the sheep, it doesn't lose those properties. It can be used for packaging. Once again, the fact that it traps air, it insulates, it also protects. It does this job on the sheep. By having wool around a sheep, it's kind of like this great big protective coating. It's also can be used for bedding. So because of the properties of the wool itself, it actually keeps mites and bacteria. And once again, that thermoregulation is really good at kind of regulating your body temperature at night, which a lot of people have a lot of trouble with. And also furniture. This is not only upholsteries, stuffings, but it is now being used in novel ways such as 3D printing, fiberglass, and plastics. We'll go more into this next. So first of all, we're going to look at how wool can be beneficial for soil. So what you have here is a breakdown of the NPK for different manures and soil amendments commonly used. So you can see the nitrogen here. Everything from chicken to pigs are anywhere between kind of 0.5% up to 3%. Mushroom compost has a nitrogen content of 1.8%, whereas wool on average is about 10%. Of course, phosphorus is an issue. We have phosphorus that ends up kind of leaking into our water systems, and it creates dead zones. So having low phosphorus at the same time of having high nitrogen is very beneficial. It's something we are seeking to do through a number of different means. Luckily, wool is like this naturally. Wool also has a lot of potassium in it, more so than mushroom compost, more than really any other manure. So this is kind of an overview. Wool is not the only solution, but it is a very interesting way to look at wool for soil. So when wool is used in agriculture, particularly when you're looking at gardening and greenhouses, considering that wool has so much water retention, peat moss is internationally known as a soil additive. What it does, it helps create soil structure and it helps retain water. On the very far right, you can see the water retention percentages of wool compared to peat moss and coir. All of these are commonly used in soil mixes. Wool clearly comes out ahead with approximately a third of its weight in water. This actually does mean that for every kilogram of wool pellets used, it can conserve approximately 500 liters of water. Here we also have the pH levels of wool pellets, rock wool, peat moss, and coconut coir, all of which are used in soil mixes. The pH level for wool is closer to neutral than a lot of the other ones. And once again, wool is a byproduct of our food system. So if we kind of project into that 1.5 million kilograms of wool that we collect every year, and that we are already collecting, could actually be made into some sort of soil amendment, that we would be returning approximately 750,000 kilograms of carbon back into the soil. Now, this is just because it's wool. Remember, wool contains 50% carbon. We could conserve or retain 750 million liters of water into the soil, which means it's not necessarily coming out of our aquifers. And it could potentially generate an additional $1.6 million for Canadian sheep farmers without actually doing anything. The reason I have this number, because at EcoWool, we do believe that wool is valuable and it does need to be paid for. Our ultimate goal, although it has not happened yet, is to be able to fully pay for at least the shearing. So we're well on our way, but there's a lot more work to do. We're now going to move on to wool's insulating properties, specifically for packaging. So a lot of us are aware of things are being shipped, and the amount of packaging for shipping has increased exponential. So at the moment, approximately 141 million metric tons of plastic packaging is produced every year. 14% of that is collected back, and less than that 14% is actually being recycled. So if you consider that wool is biodegradable, it is sustainable, it is compostable, and it's reusable, it is an ideal material to look to replace plastic packaging. Wool is also very safe, so it's not going to off-gas. It is not going to create microplastics. It has a less impactful manufacturing process. So if you have ever spun yarn, or washed fleece, or kind of done any kind of wool washing, there's still a process, but it's not going to be creating plastic out of petroleum. Studies have shown that it has almost identical properties, insulating properties, to something like polystyrene, which is not recyclable, and it's often better. And it's also 100% renewable and circular. Once again, it's a byproduct of our food system. It happens every year. And I will remind you of that IWTO number of 2 billion kilograms of wool collected a year, plus the non-member countries, and 1.5 billion kilograms of that wool that was not cleaned. Now we will get into home insulation. So commonly we insulate buildings and structures with mineral wool, fiberglass, polystyrene, cellulose, a lot of different materials, a lot that require a lot of processing. So something like mineral wool, it is literally that. It is either spun glass or spun rocks, it is slag. So there's it's very, very resource intensive. The factories are massive. It's hard to dispose of, it's hard to reuse. Whereas wool actually is very easy to install. It's very easy to reuse, recycle, or compost. It has better breathability than pretty much any other insulation out there. It has better sound mitigation. It deals with volatile organic compounds and is safe to install. The processing technology to make wool insulation has been around for decades. And once a building has been knocked down, you can take that wool and make it into something else. And it's hard to kind of go away from this, but it is 100% renewable and circular. The wool is a byproduct of our food system. And in Canada, we have the potential of 1.2 million kilograms of Canadian wool that could be made into some kind of insulation if the infrastructure and funding were there. Now I'm going to move on to kind of stuffing and bedding. So the majority of our bedding is once again made out of a petrochemical-based material, whether it be polyester or nylon, or it's made out of cellulose, plant-based. Wool is maybe one of the very first beddings that humans ever used. And if you're going to spend a third of your life sleeping, it's probably better to try and make it as healthy as possible. So wool is antimicrobial, dust mite resistant, and hypoallergenic, which means you are going to get a healthier sleep. Dust mites don't like wool. They get trapped. It kills them. So it's a really good way of reducing that aspect of living indoors. Once again, it's a natural insulator. It's what happens on the sheep, and it allows body temperature regulation. All of us have experienced kind of being too hot or too cold, getting sweaty, getting the chills. Wool helps mitigate that quite a bit. It's, once again, naturally fire resistant. A lot of fires do happen while we are sleeping. That is also when we are at our most vulnerable, is when sleeping. So if you actually imagine that a fire started, but because of wool's natural extinguishing properties and lack of flammability, that the fire goes out, it's not going to spread the way a petrochemical-based material will spread. And studies have also shown that wool bedding provides a deeper sleep because it lowers one's heart rate. So out of the wool that we produce in Canada, we have a potential of 1.1 million kilograms of wool that could be made into some kind of bedding or stuffing. We do have a handful of companies that are doing this. We need to see more. Now I'm going to go on to perhaps what I believe is the most fascinating aspect of how wool can be used in life in general. So all of the products here you see here have a very large wool component. So the boat there actually is a wool glass or wool fiberglass boat. It is a wool plastic. As you can see, it floats. This is literally a wool glass material. This is based out of kind of Australia and New Zealand, where they are also putting a lot of investment into the strong wool that they produce. The brick there you see is actually a wool brick. So wool has actually been added into this building block, and it has increased its strength, and it has increased its breathability, and it had a number of beneficial impacts. The chair seat is once again made out of wool and resin. It is a new product. It is a replacement for kind of fiberglass, which is a glass wool. And that funny machine there is something that has come out, in the last half of 2023. That is a 3D printer for wool. So whether or not this will become a thing, who knows? But it's a really interesting concept. All of these projects end up looking at wool for the properties it has. It's kind of fascinating when you combine two different disciplines of maybe industrial design, chemistry, or construction, and throw those together and see what comes out. Wool is far more than just a yarn. So all these are great ideas, but how do we actually achieve it? These are some of the things through personal experience as the founder of EcoWool and being a sheep farmer myself, the things that I've identified that would really help us reinvigorate the wool landscape. The first of all is capital investment. So we need more money. Training investment. We need people. Collaboration. We can't be stuck in silos. We need to cross-pollinate each other's ideas. Genetic investment. We need to look at the future beyond meat. Research funding. Something that is not necessarily going to have a fast payback, but will have a very long-term benefit. And of course, education funding. We don't often go out of our silos to find out what else is possible out there. So first of all, we're going to look at capital investment. So machines, buildings, setup, preparation is all very, very expensive. We used to have a lot of manufacturing. In the last 30 to 40 years, a lot of it has gone overseas. Over the last 3 years, we have seen the kind of impact that not having a stable, vital manufacturing base within the country, or at least, if nothing else, within the continent, the impacts it can have. So because wool is a physical object that can be transformed, lots of different things can be made out of it, it means we need physical assets. The majority of kind of funding out there has a cap on what you can spend on things. The majority are for research, marketing, and product development. But because we have so little infrastructure within the fiber world, we can't even effectively get things kind of to a point of a technology readiness level of 3, 4, and 5. We need to set these things up. The next is training investment. There is a huge shortage of people to work in manufacturing, construction, agriculture, food processing. We just don't have enough people. Wage increases aren't going to be the only thing that's going to get people into these industries. We need work-life balance, good training, supported training, and without those people, we don't have stable industries. The ability to perhaps be funded and paid to go overseas to learn from somewhere that does still have this kind of training doesn't exist right now. Having housing supports, childcare, immigration supports. This is the type of training investment we need to get these industries going. So now let's look at collaboration. To be able to actually have different industries cross-pollinate ideas must be done. We need to look at materials and resources and cradle to cradle circular processes, the impact we have on what we are doing to the planet, which the environmental health means our health. We already know this. We find microplastics everywhere. If we can somehow break out of that wool is yarn, wool is a textile, and put it into wool is a material, that would have a huge impact on so many aspects of our lives. Go back to who would have ever imagined putting wool into concrete or into plastic. This required somebody that had a different perspective on what they were doing, had different experiences and different sets of knowledge. It's really difficult to actually get this type of cross-pollination, not only through academia, but through funding. Even in agriculture, it's very difficult to break out of those molds that are long established. But without doing that, we will not come up with new and novel ideas. So we need funding to improve our genetics, and improve our genetics beyond just meat. To be able to have flock improvement with more of a focus on fiber instead of just meat, and genetic diversification with a focus on fiber quality or fiber use is very much needed. At the moment, the small purebred flocks tend to carry that burden, and it's also all out of their own pocket. It's also unreasonable to expect commercial flocks to carry that burden. We really need some support like all other industries. Agriculture Canada has developed animals in the past. Perhaps it's time for them to step up and do it again. It would also be interesting to find out, what could be done. Input from other industries, if we need to, which we know we do as an industry, is do we need to keep the wool cleaner? What will help there? Instead of having a farmer saying, oh, you have to change all your feeders and it's going to cost you $25,000. Maybe it's a matter of, hey, if you want to do this, we'll sign you up for a program or whatever, and we will fund it. So it's this kind of, once again, collaboration between the various aspects of our industry that need to talk with support, because it cannot come out of farmers' pockets. Now we're on to research funding. So getting research done seems simple, but it is actually quite challenging. And this I have learned through my own personal experience. It's expensive, and if it doesn't fit into a category that's already recognized, it is virtually impossible to get actual research done. So I was fortunate enough to be able to find a place to have our wool pellets be part of greenhouse trials. So this is actually going to be fully published research with actual data that will be peer reviewed. So, and this is actually the first in Canada. It is good. Luckily, I did manage to find funding, but it took a lot of work. It took a lot of support, and I still had to pay for a lot of it myself. So that kind of research access isn't readily available. If you talk to just about every farmer that has had sheep, they know the benefits of wool in a number of different ways, but other industries don't. So it kind of goes back to having research accessible to lay people, but also bringing kind of research organizations into field work. This has to be kind of a slow investment and slow funding, because going back to infrastructure, it's really difficult to do research and try and set up a manufacturing plant without a final product that's tested and know it's going to work. That is essentially, that is a trial, that is research. And without money to do that, it's not going to happen. So, and ending off, we have education funding. So this is looking at interdisciplinary funding in schools. So once again, this sense of breaking out of silos, cross-pollination of ideas, but not just through schools, because sometimes you need more experience to know what's going on in an industry to be able to have those ideas. So also through extension programs, but not necessarily something that somebody like myself, a farmer, needs to pay for, but is accessible to me. This type of funding is available in other countries. We don't really have it here, at least not in Ontario that I have found. The parameters for this type of education tends to be very specific and attached to a lot of different things. So if you don't fall into those categories, you don't get it. This also goes back to kind of looking at things in a circular fashion, to be able to say, somebody's like, oh, I have X and I need Y, and somebody else that is in a completely different area to say, oh, I have Y. You know, we need to have these larger brainstorms about what we are doing in a circular fashion. With agriculture being at such a core part of everything we do, although we are very much stuck into that farms produce food and wool is a textile, farms do so much more than food. Farms produce resources, materials, function, and a lot of it isn't even edible. I think that type of circular, holistic thinking needs to be part of all education. Without it, we are going to keep making the same mistakes, and we are not going to be able to move forward in a more sustainable future. But this cannot be on the backs of the people that are farming. It can't be out of the pockets of the people that are trying something new. And at the moment, a lot of it is, we need to change and we need support. So I'd like to thank you very much for sitting through my presentation. If you have any questions, comments, improvements, which I know are out there, please don't hesitate to contact me. ecowool.ca, hello@ecowool.ca. You can also find us on Facebook and Instagram and LinkedIn. I hope you have a very wonderful day. Thank you.